Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 3, Lesson 9, Comparing Integers and Other Rational Numbers, Part 3. Calling it Part 3 because the last couple of lessons obviously have been also about comparing integers and rational numbers. Today we're going to do a little bit of an exercise of agree and disagree and prove why. So let's jump right into it. This one's a little hard to read, so I'll read it for you. Felicia needs to write a story problem that relates to the order in which the numbers negative 6.5 and negative 10 are represented on a number line. She writes the following. During a recent football game, our team lost yards on 2 consecutive downs. We lost 6.5 yards on the first down. During the second down, our quarterback was sacked for an additional 10-yard loss. On the number line, I represented this situation by first locating negative 6.5. I located the point by moving 6.5 units to the left of 0. Then I graphed the second point by moving 10 units to the left of 0. Now, what they're asking is, do you agree that that makes sense and represents these two numbers on a number line? I'm going to give you kind of a double answer here. I'm going to give you the answer that they give you in the Eureka Math book, and I'm going to give you a second answer here. But first I'm going to label this number line. So we're going backwards, so we're going negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. We'd have negative 11 and negative 12 back here as well. So first thing, we want to graph these numbers. So on the first play, they're at the line of scrimmage, so that's 0. They haven't earned yards, which would be positive. They haven't lost yards, which would be negative. And they lose negative 6.5. So that's going to the left 6. 1, 2, 3, 4, 5, 6. And halfway would be right here. So that's negative 6.5 or negative 6.5. Probably should have labeled these as negative 1, negative 1.5, 2, negative 2, negative 2.5, but that's okay. And then negative 10 would be starting at 0 and going 10 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would graph that here. Now, it's asking if you agree that that's a good way to demonstrate those numbers. And if you don't know much about football, I think you could say that you do agree. Negative 10 is less than negative 6.5. Since negative 10 is to the left of negative 6.5 on the number line. Since both numbers are negative, they indicate the team lost yards on both football plays, but they lost more yards on the second play. So if you're just looking at each play individually, yes, then this would make sense. Because on the first play, they lost 6.5 yards. On the second play, they lost 10 yards. Now, I'm going to kind of give you a different look at this here. So that is the correct answer according to Engage New York. I'm going to tell you, if you're a football fan, this would be another way to look at it. On the first play, they lose 6.5 yards. On the second play, they lose 10 yards. If we're comparing just how much they lost on the first play by just how much they lost on the second play, then the original answer is correct. But, just throwing this out there just so you can see it, this is kind of how I think about it. If you know football, you know that when you lose 6.5 yards in the first play, you don't start at the 0 or the line of scrimmage. You start where the play ended. So you're already at negative 6.5. So instead of going negative 10 from here over, you would have to start at the negative 6.5 and go back all the way back 10 spots. So you would actually end up at negative 16.5. So anyway, the original answer was correct, that on one play they went back 6.5, on the next play they went back 10, and so that shows you how far they went back on each play. But I'm just showing you that you can also think outside the box a little bit and think, well, in football, they wouldn't be at the negative 10 after the second play, they'd be negative 16.5 yards back. Okay, another example. Manuel looks at a number line diagram that has the points negative 3/4 and negative 1/2 graphed. He writes the following related story. I borrowed 50 cents from my friend Lester. I borrowed 75 cents from my friend Calvin. I owe Lester less than I owe Calvin. So we're going to create our graph here. We know both numbers are negative, so we can just start with 0 and go back on our negative numbers. But you'll also notice that they're fractions. This is fourths. I can turn, so we have negative 3/4. I can turn negative 1/2 into negative 2/4 to make them equivalent, right? So we're going to go back on fourths. So this is negative 1/4, negative 2/4, negative 3/4, negative 4/4, or negative 1, right? You could keep going back. You'd have negative 5/4 or negative 1.25. You keep going, right? We don't need all those spots because what we have is if you borrowed 50 cents from your friend Lester, 50 cents is half of a dollar. 2/4 is half. So we're going to mark negative 2/4, and we're going to put an L for Lester. Borrowed 75 cents from your friend Calvin. 75 cents is 3/4 of a dollar, right? So we're going to go back 3/4, mark negative 3/4, and we're going to put Calvin. If you say, I owe Lester less than I owe Calvin, well, you owe Lester 50 cents, you owe Calvin 75 cents. Lester is to the right of Calvin on the number line. So in this case, I would agree with that statement. Okay, continue to move on here. Henry located 2 1/4 and 2.1 on a number line. He wrote the following related story. In gym class, both Jerry and I ran for 20 minutes. Jerry ran 2 1/4 miles. I ran 2.1 miles. I ran the farther distance. Well, I think we need to look at this in one of two ways. We've got 2 1/4, we've got 2.1. We have a fraction with a decimal. We should convert one of the two either way, right? If Jerry ran 2 1/4, and I, whoever that would be, I ran 2.1. You could convert either one, but I know that there are 4 quarters in a dollar, so I know that I can take 1/4 times 25. I'm going to end up with 2. The whole number stays the same. 1 times 25 is 25. 4 times 25 is 100. So Jerry ran 2 25/100ths of a mile, or 2 25/100 miles. I ran 2.1. I know that's 2 1/10, but if I want to make that into hundredths, I can just add a 0 here, add a 0 there. In other words, multiply by 10, top and bottom, and with 2 10/100ths. Since we have the same denominators, we can compare them, apples to oranges, right? Or apples to apples, I should say. So they both ran 2 miles. Then I ran 10/100ths of a mile, and Jerry ran 25/100ths of a mile. So he ran 15/100ths more than I did. So in this example, I would disagree because actually Jerry ran farther. Last example we'll look at here. Sam looked at 2 points that were graphed on a vertical number line. He saw the points -2 and 1.5. He wrote the following description. I'm looking at a vertical number line that shows the location of 2 specific points. The first point is a negative number, so it is below 0. The second point is a positive number, so it is above 0. The negative number is -2. The positive number is 1/2 unit more than the negative number. And one thing that would help is to create this number line. And if we're going to go by halves, it looks like we'll go by 0.5, we'll go 1, we'll go 1.5, and then we'll go 2. Below we go -0.5, -1, -1.5, and -2. Now, if we mark, let's see, we have -2, so we're going to mark that down here. And then we have 1.5, which we will mark right here. He has the numbers correct, but what he's doing is saying -2 and 1.5, right? You have -2 and you have 1.5. He's saying, well, if this was positive and you subtracted, yeah, you'd end up with 0.5, which is a half unit. But here's the deal. That is not positive, it's negative. So to look at it, we'd have to go 1/2 unit, 1 unit, 1.5 units, 2 units, 2.5, 3, 3.5. So this would be another disagree, because the difference between -2 and 1.5 is actually 3.5 or 3.5 units. So I hope you kind of see how drawing the number line there helped and seeing it visually helped. Okay, we're going to look at more examples together in class. I wanted to go over these on the video. You can go back and rewatch and see what you would get, see if you agree with these. We'll talk more again when we're face to face. Thank you for watching.